All right. So if we have superpowers, we could zoom in, we could see the little atoms breaking apart from where they were originally bonded in the reactant. We could see a whole big pile of atoms waiting to bond to make something new, and then we could see them getting rearranged and making new products. But we don't have that ability, so we have to rely on what we can see. We have to rely on clues that tell us that things are being broken apart, atoms are being rearranged, and new substances are being made. And the first clue, one of the most obvious clues, is the formation of a precipitate. This word is a precipitate. It is basically a solid that forms when two aqueous, which means water-based, solutions react. So this substance, see how it's clear? It's something dissolved in water. It's a water-based solution, an aqueous solution. So there's some sort of chemical in the water, dissolved in the water here. And this person is also holding a different water-based solution, a different chemicals in there. And look at what happens when this clear solution is added to this clear solution. The moment they touch, they start making this yellow solid, this brand new substance that wasn't there before. That's a clue that atoms that used to be here and used to be here have been broken apart, rearranged, and this is something new. There's also a new solution that's floating around it. It's not as exciting as this yellow solid, but just know that there's also a solution that's being formed. So they continue to pour the substances together. More and more and more of this solid's formed. And over here, you see a lot of it. Let me see if I can grab this. Look at those solid chunks. I know it might look like a liquid, but it's actually a solid. And if you let that sit, it's going to go down, down, down. And it's going to collect at the bottom of the test tube, or in this case, the beaker, because it's a solid. Now, why is it a solid? For some reason, and we'll get into it later, it is insoluble. It cannot dissolve in the rest of the solution that it's sitting in. And because it's insoluble, because it can't dissolve, it hangs all by itself as a solid. And if you give this time, it'll eventually form a big mass of solid that's easily separated from the rest of the solution, but you can find it on the bottom of that container. So precipitates. Look over here on the left. You see a clear liquid, another clear liquid. This produces a precipitate that happens to be a white substance. Look at all of these different precipitates. Some of them have not yet settled yet. The photographer wanted to catch them like moments after they formed, but they all will eventually settle to the bottom. So the insoluble particles will eventually fall to the bottom of the aqueous solution that's also produced. So like this red stuff is being produced, it's going to settle to the bottom, and all this other solution that's also being produced, that's not really exciting, is just going to float around it. All right, so that is precipitate. If you see a new solid form when you mix two liquids, then we call it a precipitate. Now, another sign is a color change. Now, color change, put a little star by this. It's not always a dead giveaway that chemicals are reacting. Sometimes some color changes happen, even though it's just a physical change. But look at the Statue of Liberty. This is an example of a color change that is because of a chemical change. Pure copper. Copper bonded with some oxygen from the air that's all around it. This greenish substance is different than just the original copper. So a change in color often, not always, often indicates that a chemical reaction's happened. All right, production of a gas. we've talked about gas bubbles before. This is a piece of zinc down here. Oops. This solid piece of zinc. Actually, let me cancel out of this. All right, this solid piece of zinc is reacting with the HCl, with the hydrochloric acid above it. And that is causing these hydrogen gas bubbles to be produced. So if you could zoom in on one of those bubbles, or many of these bubbles, what would we see? Well, let's think about what we already know. Here's a little graphic, and this graphic is showing the inside of the bubble filled with the hydrogen gas, and then the outside of the bubble is filled with the hydrochloric acid solution. So these H2 molecules, these gas particles, are pushing, they're colliding with each other, and they're colliding with the HCl and the water all around them, and they're pushing out, and they're forming a pocket that to our naked eye looks empty, but it's not empty. It's filled with these gas particles that were not there in the beginning. So if the gas, in this case hydrogen, forms in a liquid, bubbles become visible. As these gas particles group together and push the surrounding liquid out of the way as they rise to the surface. So those hydrogen gases, or gas molecules, push all the rest of the stuff out of the way. We look at it and say, ooh, look at that, a bubble. Each one of those little pockets is filled with hydrogen gas, and that hydrogen gas is pushing the HCl solution. There's also some water in there. It's pushing all of that out of the way. So we can't really see what's going on inside there, but these gas particles are pushing the liquid out of this area. The liquid used to be there, but now the hydrogen's there, and it makes what we see as a little bubble. All right. The next sign, nice and easy, temperature change. If you touch something and it feels hot, that's because energy is released. Where is it going? Into your hand. Your hand says, ooh, I have more energy than I used to have a second ago. That sends a signal to your brain. You interpret it as hot. If you touch something and it feels cold, think about these things. You squeeze the inner bag, pop it, a reaction happens, and then you put it on your body and it feels cold. Why? Because it's stealing your energy. It's absorbing your energy as this reaction happens. So we've seen a few examples of reactions that release extra energy, but sometimes they have to take in energy from the surroundings. And if you or your ankle happens to be the surroundings, well, then it steals your energy, or energy from your ankle. And talking about energy, if you see light being released or sound, those are two forms of energy. This is extra energy that was stored in bonds, and that is being converted. That energy that used to be stored in the bonds between atoms is being converted to sound or light as the atoms are rearranged. So as those atoms are forming new products, they don't need that extra energy anymore. They release it. And sometimes we see it as light. Sometimes we hear it as sound. Sometimes we see it as what we call fire. That's evidence. That happens because atoms are being rearranged. Sometimes we use fire to get the reaction going, but if the fire continues on its own, it's because the reaction itself is releasing extra energy in the form of fire. And then you see your light, or you feel the heat energy going into your hands from the fire. But that's a sign that atoms are being rearranged, that a chemical reaction is happening.